Hello everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second-year student at the University of Waterloo. I'm studying chemical physics with a minor in math. Today I'm going to be working through some high school level, college level calculus problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we want to be integrating ln x dx. We are going to be using integration by parts. And so the formula for that is going to look like this. And how we are going to choose u. So we're going to be using ilate. And so that just states this is inverse trig functions. We have logarithmic functions, algebraic functions, followed by trig functions, and then lastly exponential functions. So clearly, the function that we see here, we see a logarithmic function, and so our u is going to be equal to ln x, and our dv is going to be equal to 1. Let's actually write that a bit lower. dv is going to be equal to 1. And so because of this, this means that v is going to be the integral of 1 dx, and that is just going to be x, and du is going to be the derivative of ln x over dx, and so that's going to give us 1 over x. And so let's put that all in using the formula I wrote up above. And so that just states the integral of ln x by 1 dx is going to be x ln x minus the integral of 1 over x by x dx. This is going to cancel, and we'll get x ln x minus the integral of dx. And so that's just going to give us x ln x minus x plus c as our final answer. We can decide to factor out the x to get ln x plus 1, all plus c as our final answer. Sorry, minus 1. Just a little error here. Okay, and that's going to be it for this question. Okay. For our next question, we're going to want to integrate tan x dx. And so we first off need to recall that tan x is equal to sine of x over cos of x. So let's just rewrite our integral. And so we want the integral of sine x over cos x dx. And we're going to solve this using substitution. And so we are going to state our u as cos x. Du over dx is going to give us minus sine x. So dx is equal to du over minus sine x. So we're just going to put that all into what we have. And so we're going to have the integral of sine x over u, because cos x is equal to u, and then just replace our dx with this. So du over minus sine x, these two obviously cancel, and it's going to be the integral of negative 1 over u du. We can take out the negative to become the negative, so the integral of 1 over u by negative 1. Okay, and so we know that this is going to give us negative ln the magnitude of u plus c. And so we can just rewrite that. It can remain plus c because this is just a constant, so whether it's minus or positive isn't really none of our business right now because we don't have the initial value problem. And so now you just substitute u back in and you get negative ln cos of x plus c. And that's going to be our final answer. Okay, so for our next question, we want to find the slope of the tangent line to the curve y is equal to x over 1 minus x at the point 1 over 2, 1. And after that, we want to find the equation of the tangent line. So first up, we know that the slope of the tangent line is going to be the derivative of y at that point. And so we can put in our y. So it's going to be d over dx of x over 1 minus x. And then next up, we're going to make use of the quotient rule. So let's just write that down quickly. So d over dx of f of x over g of x is going to be equal to g of x by the derivative of f of x minus f of x by the derivative of g of x all over g of x squared. Okay, and so now let's write down what we actually have. We have f of x is going to be equal to x, so the derivative is going to be equal to 1. G of x is equal to 1 minus x, so the derivative is going to be equal to minus 1. And so we're just going to put all of that back into this. And so we get d over dx of x over 1 minus x is going to give us g of x, so 1 minus x multiplied by the derivative of f, that's going to be 1, minus f of x, so that is x, multiplied by the derivative of g, so that is going to be minus 1, all over g of x squared, so 1 minus x squared. So that is 1 minus x minus negative 1 times negative 1 is going to be positive, so plus x all over 1 minus x squared. These two will obviously cancel, and then it becomes 1 over 1 minus x squared as our final answer. And then, sorry, just one moment. So since it is at the point 1 over 2, 1, you're just going to put in those values here. And so we get dy over dx at the point 1 over 2 comma 1 is 1 over 1 minus 1 over 2 squared. So that is going to give us 1 over 1 over 2 squared, and this is just 4. So the slope of the tangent line to the curve y is equal to x over 1 minus x at the point 1 over 2, 1 is going to be equal to 4. In order to find the equation of the tangent line, we just write down the general equation for finding the equation of a line, and that is going to be y minus y1 is equal to m into x minus x1. Okay, and so we have the points x1, y1 is 1 over 2, 1, and m is equal to 4. So we're just going to want to put all of those values back into this equation. And it becomes y minus 1 is equal to 4 into x minus 1 over 2. So you just expand that out to isolate for y. And it becomes 4x, 4 over 2 is going to give us 2. So 4x minus 2 is equal to y minus 1. And then you just bring the 1 over to get y is equal to 4x minus 2 plus 1. And that becomes 4x minus 1. So this is going to be the equation of the tangent line. And that's going to be our final answer. Okay, so with this question, we want to find the derivative of e to the minus 2x. We're going to be making use of the chain rule, so let's just write that down quickly, where dy over dx is equal to the derivative with respect to u multiplied by the derivative of u with respect to x, because these two would individually cancel. Let's just write out the whole formula. And so for our case, we are going to have u is equal to negative 2x, which means du so we'll have u is equal to negative 2x. Y is equal to e to the power of u, therefore. Du over dx is going to be equal to negative 2. And then lastly, dy over du is simply going to be equal to e to the power of u. So let's put that all back into our equation, and we will have d over dx of e to the negative 2x is going to be e to the power of u multiplied by negative 2. So that's going to be, once you put back in u is equal to negative 2x, negative 2 e to the power of negative 2x. And that's our final answer for this one. For part B, we have d over dx of x to the power of e. For this one, we're going to be using the exponent rule, and that just states that d over dx of x to the power of a is going to be ax to the power of a minus 1. So you just drop the number out front and subtract 1 from the power. And so when we have that a is equal to e, that means a minus 1 is going to be equal to e minus 1. We will get that d over dx of x to the power of e is going to give us e multiplied by x to the power of e minus 1, according to the formula that we have here. And so these two are going to be our final answers for this question. Okay, so for our next one, we want the integral of cos squared x dx. So we're just going to recall the double angle formula of two cos squared x is minus 1 is equal to cos of 2x. That's the entire formula. And so now we just isolate for cos squared x, and we get cos squared x is equal to cos 2x plus 1 all over 2. And so we're just going to substitute this in back here because it's easier to integrate this than it is this due to the square. And so we're going to have the integral of cos 2x plus 1 all over 2 dx. So we're going to use the integral rule of the integral of a f of x dx, where a is a constant, is just a multiplied by the integral of f of x dx. So in this scenario, our constant is 1 over 2. So let's just go ahead and pull that out. And we'll get 1 over 2 multiplied by the integral of cos 2x plus 1. This is all over dx. Additionally, we'll also be using the additive property of the integral of f of x plus g of x all over dx is going to be equal to the integral of f of x over dx plus the integral of g of x over dx. So in this scenario, our f of x is going to be cos 2x and our g of x is 1. So let's just write that all out separately. And so we get 1 over 2 all into the integral of cos 2x dx plus the integral of 1 dx. This integral is easy to find. It is just going to be equal to x. This one, we're going to use substitution in order for us to figure it out. So let's go ahead and do that. We're going to be setting u as equal to 2x for this one, which means du over dx is going to give us 2. So dx is equal to du over 2. When you substitute that all in, we get the integral of cos u, and then you put in our dx, so du over 2 is going to be equal to 1 over 2 multiplied by the integral of cos u du. This we know will give us sine u, and so let's put that in. And so this means that this is equal to 1 over 2 multiplied by sine u, and then just put back in the 2x that we know u is equal to, and we get 1 over 2 sine 2x. And so now we put this all back into here, and we will get 1 over 2 multiplied by 1 over 2 sine 2x plus x. And this will give us a final answer of x over 2 plus sine 2x over 4. And then don't forget about the fact that it was a boundless integral to begin with. And so we're going to have to add the plus c at the end, of course. And so we get plus c. And that will be our final answer. Additionally, you can further simplify this using the double angle formula to this form, but either forms would be acceptable. Okay, so next up we want to evaluate the indefinite integral as an infinite series. And so we know that arctan, so in order to do this, first we need to figure out the infinite series for arctan. And then you put in x squared in the position of x to figure out the infinite series of arctan x squared, and then we're going to take the integral of all of that. And so we know that arctan x, or inverse tangent, is going to be the integral of 1 over 1 plus x squared. And then we're going to make use of our little friend here that just simply states that 1 over 1 minus x can be expressed as the infinite series from n is equal to 0 to infinity of x to the power of n. And so now when we substitute in 1 over 1 minus negative x squared, which is what we have here, 1 plus x squared, you simply put in the negative x squared in the position of x. So n is equal to 0 to infinity, negative x squared to the power of n. We can pull out the negative as a negative 1 to the power of n and leave this as x to the power of 2n. So let's write that all out. So it's from n is equal to 0 to infinity of negative 1 to the power of n multiplied by x to the power of 2n. So that means that we can express arctan of x as the integral of the summation, so the infinite series, negative 1 to the power of n, x to the power of 2n. Okay, and so now, because these two don't really involve, this is over dx. Because these two don't really involve any x dependence, the only thing that we're going to be really integrating here is going to be the x to the power of 2n. And just remember that the integral of x to the power of a is going to be 1 over a plus 1, x to the power of a plus 1. In this scenario, our a is going to be equal to 2n, and our a plus 1 is going to be equal to 2n plus 1. So this means that arctan of x is going to be, as mentioned, the integral of this infinite series. And to write out what that is going to be, it is going to be the summation from n is equal to 0 to infinity of negative 1 to the power of n, x to the power of 2n plus 1, all over 2n plus 1, according to this formula. So now we just put in our x squared, since we have what arctan x is. So arctan x squared is going to be from n is equal to 0 to infinity, negative 1 to the power of n, x squared to the power of 2n plus 1, all over 2n plus 1. We know that we're going to multiply these two according to exponent rules. So it becomes from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 4n plus 2, all over 2n plus 1. Okay, so now we need to remember that the question is asking for the integral of arctan x squared. So let's go ahead and find that. And that is going to be the integral of what we have here. So from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 4n plus 2, all over 2n plus 1. So again, similar to how we did the one here, because x to the power of 4n plus 2 is the only variable with x dependence, we're just going to use this same exponent rule when it comes to integrating. And so our a is going to be 4n plus 2, which means our a plus 1 is going to be 4n plus 2 plus 1, which is 4n plus 3. Which means that this will become the infinite series -1 to the power of n, x to the power of 4n plus 3, all over that 2n plus 1 will still be there, multiplied by 4n plus 3. So this one is from the first integral we found to find arc tan in the first place, and then the 4n plus 3 is from integrating arctan x squared itself. And so this is going to be with the radius of convergence of 1. And that's our final answer. Okay, so for our next question, we are looking for the integral of sine squared x cos squared x all over dx. So initially we're going to use the double angle formula stated here of sine 2x is going to be equal to 2 sine x cos of x, which means that sine x cos of x is equal to sine 2x over 2. And that means that sine squared x cos squared x is equal to sine squared 2x over 4. And then furthermore, we are going to get rid of this. So just so that you are still following, we're going to put this into our question. So sine squared x cos squared x dx is going to be equal to the integral of sine squared 2x over 4 dx, because we found that these two are equal. And then we're going to simplify this further by getting rid of the sine squared 2x, and we're going to be using the formula that sine squared of x is equal to 1/2 1 minus cos 2x. And so this means that sine squared of 2x is equal to 1 over 2 1 minus cos of 4x. And so again, put that right back in. And so we will get the integral of 1 over 2 1 minus cos 4x over 4 dx. And then it will be easier to find this integral than the first one. And so we just proceed. We can go ahead and pull out 1 over 2 over 4 is going to be 1 over 8. That becomes 1 over 8, the integral of 1 minus cos 4x dx. And then next up, we can separate these two as we did in the earlier question. So it becomes 1 over 8 into the integral of 1 dx minus the integral of cos 4x dx. And then similar to last time, we know that this is going to be equal to x, and we are going to use substitution for this one. We are going to set u as 4x, which means du over dx is going to be 4, which means dx is equal to d over 4. That means that the integral of cos 4x dx is going to be the integral of cos u du over 4. We can pull out the 1 over 4 and it becomes the integral of cos u du. And that is going to give us 1 over 4 multiplied by sine u. So 1 over 4 sine 4x. Put that all back into this formula we have. And so it becomes 1 over 8 multiplied by x minus sine 4x all over 4. And so if you want to write that out, we can write that as 4x minus sine 4x over 4 all over 8. And that can finally be rewritten as 4x minus sine 4x all over 4 by 8 is going to give us 32. And then again, let's not forget about the open bounds on the initial question up here, which means that we need to add a plus c. And that is going to be our final answer for this question. So you need to be careful when you're pulling out all of these fractions. It's best if you pull them out of the integral before you do anything with it. That way you don't forget about it as what has happened here in the solution. Okay, so next up we want to find the integral of arctan x dx. And so again, just remember the acronym that we have here of inverse, trig, logarithmic, algebraic, trig functions, and exponential. And these are all functions. And that is because we will be solving this by integrating by parts. So this will help in the choice of u. So let's go ahead and write down the formula. So the integral of u dv is going to be equal to uv minus the integral of v du. Be careful that you don't accidentally interchange the two because they look so similar. So v du. And so we see an inverse trig is the first thing that pops up, which means obviously our u is going to be equal to arctan x. Our dv is going to be equal to 1, which means v itself is equal to x. And our du is going to be equal to 1 over 1 plus x squared dx. And so let's go ahead and fill everything in. And so we got the integral of arctan x dx is, sorry, this is also 1 dx. is equal to arctan x by x minus the integral of x multiplied by 1 over 1 plus x squared. Dx. Okay, so this is going to give us x arctan x minus the integral of x over 1 plus x squared dx. So again, this is another integral that we're going to need to figure out. So let's go about doing that. And we get that if we set u as equal to 1 plus x squared, which means du over dx is equal to 2x. So dx is equal to du over 2x. We're going to put that all back in, and we get the integral of x over 1 plus x squared, x over u, because we've set u as 1 plus x squared. And then dx is equal to du over 2x. These two will cancel, leaving d over 2, and so we get 1 over 2, the integral of 1 over u du. And so that will give us 1 over 2. We know that this is going to be giving us ln the magnitude of u. And then we put in what our u is, so it's 1 plus x squared, so we get half into ln the magnitude of 1 plus x squared. And so when we put that in back here, we get that the integral of arctan x dx is equal to x multiplied by arctan x minus a half the ln of 1 plus x squared. And let's not forget about the plus c. And this is going to be our final answer. Okay, for our next question, we are looking for the derivative of cos squared x. We're going to be using the chain rule here, and it just states that dy over dx is going to be dy over du multiplied by du over dx. The two would naturally cancel. And so in our question, we will set y is equal to u squared. U is going to be equal to cos x. This will mean that dy over du, using the exponent rule when it comes to derivatives, is going to give us 2u, and du over dx is going to give us negative sine x. And so we just put that all back in to our equation here, and we get dy, which is so du squared over dx is going to be dy over du, so 2u multiplied by du over dx, so negative sine x. And then we're just going to substitute u for cos x, and so we get d cos squared x over dx is going to give us 2 multiplied by cos x multiplied by negative sine x. And then we can just pull out the negative to be out front, so 2 sine x cos x, proving that what is given in the question is correct. Next up, we will want to find the integral of secant cubed x dx. Okay, so in order to find that, again, we will be using integration by parts. So let's just write down the formula. And remember that we will be choosing our u according to iolate. So let's just write that down. Inverse trig, logarithmic, algebraic, trig functions, and exponential functions. Okay, and so we see that we have the inverse trig function of secant x. And so we are going to state that u is equal to secant x, and dv is going to be equal to secant squared x dx. This will mean that du will give us secant x tan x dx, and v will give us tan x. So we're going to plug that all back into our formula, and we get the integral of secant cubed x dx is equal to uv, so secant x tan x minus the integral of v du. Yeah. And so tan x multiplied by secant x tan x, so that's going to be tan squared x secant x dx. Okay, and so again, we will need to figure out how to get this integral. And so let's go about doing that. We can get rid of the, that tan squared x is going to be equal to secant squared x minus 1. So let's go ahead and put that in here. And so we get the integral of tan squared x secant x over dx is equal to the integral of secant squared x minus 1 into secant x dx. And when we multiply that out, that would be equal to the integral of secant cubed x minus secant x dx. This is cubed. And then furthermore, we can rewrite this by separating it using the integral of f of x plus g of x is equal to the integral of f of x plus the integral of g of x. And so this is going to be equal to the integral of secant cubed x dx minus the integral of secant x dx. And so now let's write that all into what we initially have up here. And so the integral of secant cubed x dx is equal to secant x tan of x minus the integral of, so this is what we had, this is equal to, so the integral of secant cubed x dx plus, because minus of minus is positive, the integral of secant x dx. What we're going to do is we don't know this is what we're trying to find, so we're going to bring it over to the other side so we can isolate it. And this will give us 2 multiplied by the integral of secant cubed x dx is equal to secant x tan of x plus the integral of secant x dx. So now we need to go about finding this, and then once we add the two, we're going to divide them by 2 in order to find our final answer. And so how we can go about finding the integral of secant x dx is we will actually multiply the entire thing by tan x plus secant x over tan x plus secant x. So we're going to state simply that 1 is equal to secant x plus tan x over secant x plus tan x. So we're going to multiply this by 1. And so we get the integral of secant x multiplied by plus tan x all over secant x plus tan x dx. And so we're going to write this out again to get secant squared x plus tan x secant x over secant x plus tan x dx. And then we go about solving this by setting u is equal to tan x plus secant x, which means that du over dx is going to give us secant x multiplied by tan x plus secant squared x, which is exactly what we need for it to cancel, because this will mean dx is equal to du over all of that. And so when you put it in, we get that the integral of secant x dx is going to be equal to the integral of secant squared x plus tan x secant x over u multiplied by du over the same thing. These two are going to cancel, and we're going to get that this is equal to the integral of 1 over u du. And we know that this will give us ln of the magnitude of u plus c, but we're not going to write that right now because this is not what we're looking. This is not our end goal. Our end goal, we always need to remember, is the integral of secant cubed x. And this is just a part of that. So we'll add the plus c at the complete end. So for now, we just write back in what our u is. And so we know that the integral of secant x dx is going to be ln of u, so the magnitude of tan x plus secant x. Okay, and so now we put all of that back into what we have here. And so we have 2, the integral of secant cubed x is going to be equal to secant x tan x plus the ln of the magnitude of tan x plus secant x, because that's what we got. Remember this integral as? And so let's add the plus c now. Actually, let's move over the 2 first, so over 2. And so we got the integral of secant cubed x is equal to secant x tan x plus the ln of the magnitude of tan x plus secant x all over 2. And then now is when we can add our plus c, because this is our final product. So plus c. And that is going to be our final answer. Okay, for our next question, we want to figure out how to state work as an integral. And so the answer given here is the calculus 1 method. I'm going to show you how to derive this fact. And in calculus theory, you're not going to assume that f of x is equal to kx in any form or manner. You're just going to take f of x as f of x. And so we know that the really simple version of this question at the high school level can be stated as this. So we know that if we have this 2D question, the work done by a force imparted at this angle to move object M through a distance vector D is going to be the dot product of the two. And this is going to be the magnitude of F multiplied by the magnitude of D cos theta. And this is in the scenario that F is constant. But we know that this is not always the truth. A very good example of this is rockets trying to reach escape velocity. The force that we would be dealing with is the gravitational force, and that of course is dependent on your distance from the surface of the Earth, and that is changing as the rocket is trying to reach escape velocity, which means that the force will not be constant. So how we state it as an integral is we're going to take account of the fact that f is changing, and we're going to integrate f as it changes along its path. And so a good way to imagine this is take an object moving along path C, and for this very short part of this path, it moves dl, and the vector tangent to it is going to be t, and it is moving in a vector field f. So it is moving along path C that is parametrized or described by r of t, and moving through this vector field of f that is also going to be dependent on r. In this case, the work done over this very small part is going to be what we've calculated. So the tangential force dotted with dl. So that's just going to be dl, not dotted with the force dot product with this distance, and that's going to be the tangential force multiplied by dl. And so let's write that out like that. And so we know that the force tangent is just the dot product of the force and the vector that is tangent. And lastly, we know that the tangent vector is going to be equal to the derivative of the vector describing the path over the magnitude of that derivative. Okay, and so now this will mean that when we want to find the work, it is going to be equal to the integral of dw, since it's a very small piece of the entire path. And that would mean the integral of ft dl, which would be the integral of f dot t, but we're going to write in t as this. So f dot r prime t over the magnitude of that dl. Okay, and then next up we need to remember the fact that dl is equal to the magnitude of the derivative of that vector dt. And so now let's put that in for our dl. We get the integral of the force dot the tangent vector, and then we're going to put in our dl. dt. These two will of course cancel out, and so this will give us the integral of f dot the derivative of the vector describing the path dt. And then lastly, you just need to remember that prime t is equal to dr over dt, which means that we can state dr is equal to this, which will simplify this to become the integral of f dot dr, and this will be our final answer. And so a really good example question for this is, as I mentioned, a rocket trying to escape Earth's gravitational pull. So we're going to use this equation that we've derived to find out how much work is done during that process as the force is changing. So as a quick sketch, we have this as our space. And so let's draw the Earth here. Okay, and we know that we're going to be trying to go from z is equal to RO, which is the surface of the Earth, to a point where the rocket has reached escape velocity, and it is at z is equal to RO plus h. Okay, and then later on what we're going to do is set the limit of this work function as h approaches infinity. So as the rocket gets infinitely far from the Earth, which is when you've escaped the gravitational pull completely, theoretically. And so we know that our path C, so first off, we know that the force that we will be facing here in terms of r is going to be negative g mm over r squared multiplied by r hat. Next up, we know that you're traveling, so the path is going to be along C, and C is a straight line that is along the z-axis. And so what we can do is set dr is equal to, z hat dz. And so along this path, x is equal to 0, y is equal to 0, r is going to be equal to z, and r hat is equal to z hat. And so now we just put that into this to get negative g m over z squared z hat. Okay, and so now we're just going to put all of that into the equation we found for the work done. So the work done is going to be equal to the integral of f dot dr is what we found. And so that is going to be the integral of negative g mm over z squared z hat. And then we know dr is going to be z hat dz. And so when we take the dot product of those two, and it's going to be from z is equal to RO to z is equal to RO plus h, because we're finding how much work is done in between here and here. Okay, and so when we take the dot product and pull out any constants, we get negative g mm, the integral from RO to RO plus h of 1 over z squared dz. And for this, we can just easily use the integral of exponents in order to find out what that is. And so for a final answer, you will get g mm multiplied by 1 over z. And it's a bounded integral, so you want it from RO to RO plus h. And so when you actually do that out, you will get g mm multiplied by 1 over RO plus h minus 1 over RO would be the work done. as the velocity goes from the surface of the Earth to height h above the surface of the Earth, so RO plus h. And then remember, lastly, we want this to be escape velocity, which is when h is going to infinity. So we'll want the limit as h approaches infinity of w. And so this would be the limit as h approaches infinity of GMM 1 over RO plus h minus 1 over RO. And this is going to give us the answer of negative GMM over RO. And this would be the total work done as the rocket escapes Earth's gravitational pull. Since it's negative, that means that the gravitational field itself is gaining energy and work is done by the force to the field. And that's going to be our final answer. And so as your general equation for how to find the work done, we have it here. And you can use it for problems like the one I've done here. Okay, next up, we would like to find the derivative of the hyperbolic trig function of cos x. Okay, and we need to remember that cos h of x, so the hyperbolic trig function, is equal to e to the x plus e to the minus x over 2. We're going to be using the, additive property of derivatives. So d over dx, write them down here, of f of x plus g of x is going to be d over dx f of x plus d over dx g of x. Additionally, we will be using the constant property, which is a by fx is equal to a multiplied by the derivative of fx. So let's go ahead and use that in this question. So we begin by rewriting it. So d over dx of this is going to be d over dx of what it is equal to, so e to the x plus e to the minus x over 2. Let's go ahead and use this rule to pull out the 1 over 2. So it becomes 1 over 2 d over dx of e to the x plus e to the minus x. And we're going to use this rule to separate them into 2. This would be 1 over 2 times d over dx of e to the x plus d over dx of e to the minus x. Now we know this already is going to give us e to the x. This is a different case because we have the minus in front of the x. So let's go ahead and figure out what that is. We will use the chain rule and look for d to the dx of e to the u. And recall dy over dx is equal to dy over du multiplied by du over dx. And so u in this case is minus x, so du over dx is equal to minus 1. So this would mean that d to the minus x over dx is going to be e to the minus x times negative 1. So minus e to the minus x. And so now when we plug that all back into what we have here, we will get that d over dx of this function is going to be 1 over 2 into e to the x plus negative e to the minus x. And this will become e to the x minus e to the minus x over 2. This is actually another hyperbolic trig function that is of sine. So it's going to be equal to sine hx. And that is going to be our final answer. our next question, we would like to integrate x e to the minus x over dx. So again, we're going to make use of the acronym. And that is because I've recognized that it is an integration by parts question. And so inverse trig, log functions, algebraic functions, trig functions, and exponential functions. So the first thing I see here is the algebraic before I hit the exponential. So what that is going to mean is that u is going to be equal to x, and dv is going to be equal to e to the minus x. This will mean that v is equal to negative e to the minus x dx. Sorry, no, not dx. And that du is equal to 1 dx. That's where it's supposed to be. Okay, so using the formula that we can just write down quickly here. And we put in what we have. The integral of x e to the minus x dx is going to be u times v, so negative x e to the minus x, minus the integral of v du. So negative e to the minus x dx. We can pull out this negative and it becomes a double negative, so it's plus, so minus x e to the minus x plus the integral of e to the minus x dx. We already know the integral of e to the minus x because we calculated it here to find v. So we'll get negative x e to the minus x minus e to the minus x. And then we will have a plus c because we found our final answer. And that's it for this question. You can decide to pull out the e to the minus x if you feel like, but the plus c will have to be outside of those two brackets, outside of the brackets, because plus c is a constant. For our next question, we will want to find the derivative, so d over dx of 3 to the power of x. For this one, we're going to be using some logarithmic properties. So first we're going to set y is equal to 3 to the power of x, right? And so that means we'll be looking for d over dx of y. And so we first start off by taking the ln of both sides, and we get ln y is equal to ln 3 to the power of x. We need to remember the logarithmic rule that for the same base, so log e, let's call the variable a, so this would be ln to the power of x is equal to x log e a, and we're going to use that on this side of the equation. And so we get ln y is equal to x ln 3. Next up, we want to take the derivative with respect to y on both sides, with respect to x on both sides. So ln y is equal to d over dx of x ln 3. Now, since we have y is equal to 3 to the power of x, we're going to pretend we don't know what y is. We just know that it is dependent on x. In this scenario, we know that this is going to be equal to the derivative of ln itself. So that's going to be 1 over whatever its value inside here is going to be, multiplied by d over dx of y. So this is the product rule. And then we're going to use d over dx x ln 3 is, pull out the ln 3 because it's a constant, and d over dx of x this will become 1 over y d over dx. Y is equal to ln 3 by 1, which is just ln 3. Next up, we're going to put back in y in terms of x. So we know this will be 1 over 3 to the power of x, d over dx, 3 to the power of x is equal to ln 3. And then we're just going to isolate for this because this is what the question is asking for. So d over dx of 3 to the power of x is equal to 3 to the power of x multiplied by ln 3. And that is going to be our final answer. Okay, next up we want to find the first and second derivatives of 1 over ln x. So to find the first derivative, we are going to set u as ln x. So du over dx is going to be equal to 1 over x. And then we're going to use the chain rule here and set y is equal to u to the power of negative 1. So we know dy over dx, which is du to the power of negative 1 over dx, is going to be equal to dy over du multiplied by du over dx. Let's fill those in according to this. Let's not forget that the exponent rule, we can use it here to get negative u to the negative 2. And so this will become dy over du, so negative u to the power of negative 2 multiplied by du over dx, so 1 over x. This will become negative 1 over ln x squared by 1 over x, so negative 1 over x ln of x squared. So that is going to be the first derivative. Next up, we want to find the second derivative. So d squared 1 over ln x over dx. That is just going to be the derivative of the first derivative. So d over dx of negative 1 over x ln x squared. And then for this one, we are going to be using the quotient rule. Let's just write it down quickly for us here. We know that d over dx of f of x over g of x is going to give us the derivative of f of x multiplied by g of x minus the derivative of g of x multiplied by f of x all over g of x squared. And so now let's find all of the numbers that we need to find on the side, and then we're just going to plug them back into the equation. And so we know that f of x in our scenario is going to be equal to negative 1, which means that the derivative is going to be equal to 0. G of x is equal to x ln x squared. The derivative, we're going to use the product rule for this one. And it will give us the answer of g prime of x is equal to d over dx of x. So that is going to give us 1 multiplied by ln squared x plus the derivative of this multiplied by x. So x multiplied by the derivative of ln x squared. For this, you can use substitution and you will get 2 ln x. And then 1 over x squared. Sorry, 1 over x as the derivative of ln x itself. These two will cancel, and you will get ln squared x plus 2 ln x. We're going to put that all back into the quotient rule, and we will get 0 multiplied by g of x, so x ln squared x minus ln squared x plus 2 ln x, all multiplied by f of x itself, so minus 1, and then all over g of x squared, so x squared ln to the power of 4x. This will become 0, minus 1 times minus 1 is positive, so this becomes ln squared x plus 2 ln x over x squared ln to the power of 4x. We can cancel out one of the lns, so this would cancel, one of those would cancel, and we would get ln x plus 2 over x squared ln cubed x. Let's just scroll up to ensure that there's nothing else we're supposed to search for. So this is, as we know, d over dx of -1 over x ln squared x. Yeah, and so that's exactly what we're looking for, and this is our final answer. Okay, for our next question, we would like to evaluate the integral of 10 to the power of 5x multiplied by secant cubed x dx. And so of course we're going to need to simplify this too. We need to remember that tan squared x plus 1 is equal to secant squared x. Okay, so now we isolate for tan squared. It's equal to secant squared x minus 1. And then we're going to square both sides to get tan to the power of 4x is equal to secant squared x minus 1 all to the power of 2. And then we're going to plug this in and just replace tan to the power of 5x as tan to the power of 4x by tan x. This is going to leave us with the integral of secant squared x minus 1 multiplied by tan x. Sorry, this is squared. Multiplied by secant cubed x dx, I believe. Yeah. And so we just need to note that this can also be simplified by taking it as secant squared x into secant squared x minus 1 squared, that multiplied by tan x by secant x dx. So we're just separating this cubed into a squared by to the power of 1. And then lastly, what we're going to do is we're going to use substitution. If we set u as secant x, that means du over dx is going to be secant x multiplied by tan x. So dx is equal to du over secant x multiplied by tan x. Let's put that all back into our equation. And we're going to get the integral of u squared into u squared minus 1 squared multiplied by tan x secant x. We're going to leave that alone, and then you put in dx, so du over tan x secant x. This will allow these two to cancel, so we're just finding the integral of u squared into u squared minus 1 squared over du. this is much easier as we can just use the exponent rule. So first let's expand that out, and it'll become the integral of u to the power of 6 minus 2u to the power of 4 plus u squared all over du. And then we're just going to use the exponent rule, and this will become u to the power of 7 over 7 minus 2 over 5 u to the power of 5 plus u over 3 to the power of 3. And of course there'll be a plus c that we can add later on. Let's go ahead and remember the fact that u is equal to secant x. We're just going to fill that in here. And we will get secant x to the power of 7 over 7 minus 2 secant x to the power of 5 over 5 plus secant x cubed over 3. And then we're going to have the plus c. If we'd like to simplify this further, we can take into account that secant x is equal to, let's ensure we have one denominator first here. And so that will become secant cubed x into 15 secant to the power of 4x minus 42 secant squared x plus 35. That is all over 105 plus c. You can leave the final answer like this, or you can take into account the fact that secant x is equal to 1 over cos x, so write this in terms of cos x instead. And that's going to be everything. Okay, next up we want to find the Maclaurin series for cos x to compute cos of 5 degrees, correct to 5 decimal places. So let's write the general formula for the Maclaurin series, and that is the summation from n is equal to 0 to infinity of the function once you take the derivative to the nth degree, evaluated at 0 over n factorial multiplied by x to the power of n. And so in our case, we have f of x is equal to cos x, right? So let's go ahead and calculate the first couple of derivatives. So the derivative of this is going to be negative sine of x. The derivative of that is negative cos of x. And this will give us sine x cos x, and you just keep going back and forth. 3, 4, 5. Let's go ahead to the sixth one. 3, 4, 5, 6. Okay, so evaluated at 0, this is going to be 1. This is going to be 0. This is going to be negative 1, 0, 1, 0, negative 1. So you see we're just basically through another series. And so now let's write out this in order to fill in our values. So this is from n is equal to 0 and so that would be f prime yeah, this is going to give us f of 0 plus f prime 0 over 1 factorial and this is by x to the power of 0. Sorry, this is x to the power of 0, so this is x to the power of 1, x to the power of 2 over 2 factorial plus the third derivative, x to the power of 3 over 3 factorial, and it goes on. And so now let's actually fill in our values, but let's make the note that all of our oddly, when you take the derivative to an odd number, so the third one, the first one, the fifth one, so on and so forth, it's going to be sine of 0, and that is going to give us a 0. So all of these odd terms are going to actually cancel out because the coefficient is going to give us a 0. And so in our scenario, we will get the summation of 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial. So now the reason why it's going positive, negative, is because of the coefficient caused by the cos term. So it's 1, negative 1, 1, negative 1. So that's simply expressed here. And so now if we want to figure out what that would look like in the summation form, because of the alternating pattern of it between positives and negatives, let's throw in a minus 1 to the power of n. That way when it's 0, it will be positive. To the power of 1, it'll be negative. To the power of 2, it'll be positive, so on and so forth. We're going to have x to the power of 2n. So that the x values can match it. So when it's 0, you have x to the power of 0, 1, x to the power of 2, 4, x to the power of 2 by 2, so 4, and it all makes sense like that. And lastly, we see here, we're going to have 2n factorial. And that is going to be what our cos of x Maclaurin series looks like, just based off of us using the general formula and plugging in the values when we're using cos of x. And so now, since we want to find 5 degrees, we're going to first need to change it into radians. So it would be 5 by pi over 180. And that is going to give us pi over 36. And then we're simply going to plug that into our series. And so cos of pi over 36 is going to be equal to the series that we have found. So pi over 36 in the place of x, all over, it was 2n factorial, right? And so now we're just going to want to evaluate the first couple of terms. We actually only need until here in order for it to be quite accurate with what you'd plug into your calculator, because the decimal points past then won't necessarily matter. So that would be 1 minus pi over 36 squared over 2 factorial plus pi over 36 to the power of 4 over 4 factorial. You can go on if you feel like. Okay, and so now we're just going to use these two in order to find what we need to find. So that would be equal to 1 minus, you just plug those two values into your calculator. And what you actually will get is going to be 0.996192228. 2, 2, 8, 2, 3, and that's actually, my apologies, if you use just the first two. The reason why it doesn't matter past this is because your calculator won't give you decimals to the point that it will matter. And actually, when you plug it into your calculator, cos of 5 degrees really quickly, you will get 0.996194698. And so we see that it's the same until here, And the reasoning why is because we just made an approximation by getting rid of the rest of the terms that would have made it correct to that point. And so this is going to be your final answer. So it's best to just leave it in the form of 0.99619. Okay, and those are all the questions I have for you today. I hope you enjoyed today's Q&A. If you'd like to be aware of when OneClass does post other videos, be sure to hit the subscribe button and the bell next to it so that you get the notification when we do post. If you'd like to post questions of your own so they can be answered on the live stream, be sure to check out the links in the description. This has been Marlyn from OneClass, and I hope to see you next time.